Today, this is my group,
ADIL,
Azab, and myself, SHIVANK, and we are going to explain how the Arduino works. Our project is on how the fan speed is going to be controlled by a temperature sensor and how it's going to function.
So these are the components that are used in the Arduino in our project. So this is the cable over here, which is connected to the laptop and to the board. It's a driver, and this is the board, Arduino board, that uses the microcontroller to help us connect the sensor together. And then this is the breadboard, this white piece over here, that acts as a hub in which we connect all the wires and all the components, like the LCD over here, which helps as a display screen, and the potentiometer over here, this white one, which acts as a contrast. If we twist it, it will help us see the display. And then this is the black one over here. This is a temperature sensor, and also we're using a fan, a 12-volt fan. The temperature sensor helps us in sensing the temperature. So yeah.
Okay. I'm going to demonstrate you. If I touch the hot water to the sensor, then the temperature is going to increase. Because of that, the fan speed is going to increase. Now I'm going to touch this sensor with the hot water. As you can see, if it now it's 82, 81. If I touch, the temperature is increasing. 84, 85, 86, 87, 88. Because of which the fan speed is increasing. 51, 48.
So as you can see, it's speeding slowly.
Before the temperature was around
80, 81.
Now it's 86.
It's 86, 87. So as you can see, as the temperature is increasing, the fan speed is also increasing. And we have specified the minimum temperature to be 70 degrees Fahrenheit and the maximum to be 105 degrees Fahrenheit.
If I remove the hot water from the sensor, you can see the temperature is decreasing little by little, because the fan speed is also decreasing.
This is the ITX 1000 Arduino project. This is the fritzing application demonstration of our project. Over here we use the breadboard, and this is the Arduino Uno, the microcontroller. Components used is LCD screen, potentiometer, temperature sensor. We use a fan also, but since there's no fan component in fritzing software, we use a sticky note to show that we are using a fan. Now to get the power supply, we connect the 5-volt from the LCD, from the Arduino, to the positive side of the breadboard, and we connect the ground to the negative side of the breadboard. Now to connect the LCD to the breadboard, we connect the VSS pin to the ground, and then we connect a VDD pin to the power supply, and then the third wire here, the VO, is connected to the potentiometer, which helps to adjust the contrast, and that helps the user to see the screen clearer or better. The potentiometer also has two wires that is connected to the ground, and the other wire that is connected to the power supply. The LCD is also the next wire in the LCD. The RS is connected to pin number 12 in the Arduino, and then the next pin is connected to the ground. This pin is connected to the ground, the RW wire, and then the next pin here, the E pin, is connected to pin number 11 in the Arduino board. Then the data bus line, pin number 11 of the LCD, is connected to pin number 5 in the Arduino. The next data bus line over here, data bus line number 12, is connected to pin number 4. The next data bus line that is pin number 13 of the LCD is connected to pin number 3 of the Arduino board right there, and data bus line pin number 14 is connected to pin number 2 of the Arduino board. Then the LED plus over here, this wire, the LED plus is connected to the power supply, that is a positive side of the board, and the next wire, the LED minus, is connected to the negative side of the board. Using a temperature sensor also, which uses 3 wires. One is connected to the ground, the other wire is connected to the positive, that is the power supply, and the other wire is connected to pin number A1 in the Arduino. And the fan also has 3 wires. One is connected to the ground, and the other one is connected to the positive side of the board, and one more wire which is connected to pin number 6 in the Arduino board. Schematic. Over here we can see the potentiometer, LCD screen, temperature sensor, and an Arduino. We can see here how it's connected. It's connected to the ground, and here also the VDD is connected to the 5 volt over here, right there. And the third one, the third VO is connected to the potentiometer. RS is connected to pin number 12. RW wire is connected to the ground. The E wire, the E pin, is connected to pin number 11, and then the 4 data bus lines that are connected over here. Over here, 4 data bus lines. LED plus, which is connected to 5 volt, and LED minus, which is connected to the ground. This is the virtual representation of our project. Thank you. Now I'm going to explain the Arduino coding of our project. Over here we can see that we're including the LCD library, which is liquid crystal, hashtag include liquid crystal. Over here in the second line, we're initializing the library with the number of interface pins, that is 12, 11, 5, 4, 3, 2. Over here we're assigning the variable temp pin to pin number A1 in the Arduino board. Over here the fan variable is declared here and is assigned to the pin number 6 in the Arduino board. And temperature temp variable, fan speed, and fan LCD are the variables that we will assign values to later in the coding. Minimum temperature, here we are assigning the value 70 and maximum temperature 105. Now in the void setup, over here we are using the pin mode function to get the output of the fan and the input of the temp pin, and here we're using the code LCD begin to start up the LCD. Now going for a void loop. Over here we can see that the temp variable uses a function called analog read, which reads the temperature from the temperature sensor. And then over here we can also see that the temperature after getting the value will be multiplied by this numerical. And over here we're also setting the fan speed to default, which is 0. Next we go on to an if statement where if the temperature is less than minimum temperature, then the fan should not spin. We're using another if statement where the temperature is greater than the minimum temperature, then the fan speed should be mapped. It's a function, map function. Fan speed should be mapped and the actual speed of the fan should be stored in fan speed. In the second, in fan LCD, which is a map function, should also get the fan speed, and that should be displayed on the LCD. So we're storing the fan speed in the fan LCD, and then using another function called analog write to spin the fan at fan speed, and using another function called digital write to make the fan spin. we're using an else if statement, which shows that if the temperature is less than the maximum temperature, then the fan speed should use a function called map, which gets the actual speed of the fan, and the fan LCD, which uses a map function, which gets the fan speed to display on the LCD screen. Of analog write is a function to spin the fan at fan speed, and digital write to make the fan spin. We are using an else statement in case if we don't get a temperature from the temperature sensor. So the fan speed again uses the map function to get the actual speed of fan, and the fan LCD will uses the map function to get the fan speed to display on the LCD. Analog write function to make the fan spin at the fan speed, and digital write to low to not make the fan spin. Here also in the next line over here, we use the LCD code, which LCD print over here that prints the word on the LCD print temp over here, which prints the temperature, that is the temperature on the LCD, and then set cursor, which sets the LCD cursor to the next line. And we're using a delay over here, which delays the LCD screen in milliseconds for 200 milliseconds. Then we're clearing the LCD screen using the clear function. This is the code used for our Arduino project. Thank you.